So we have to start with u, which is x squared plus 2x, and our dv is cos x dx. So du will be 2x plus 2, and v will be, the integral of cos x is sin x applying integration by parts formula. uv minus integral of v du. So u is x squared plus 2x, v is sin x minus integral of v, which is sin x, and du, which is 2x plus 2. This will be dx. X squared plus 2x sin x minus integral of integral of 2x sin x, because I'm multiplying this with sin x, so it becomes 2x sin x plus 2 sin x.
Sorry, but why didn't we integrate before we multiply? Like integrate as we did at the beginning.
In the first part.
No, here like you distributed the sin x multiplied by 2x and then multiplied by 2.
Yes.
Can't we like immediately integrate, or we should like simplify and then integrate?
Yeah, it's completely up to us. We can before simplification we can actually integrate it. Either we are going to get the same answer.
Okay, so it will not affect.
Yeah. So it is 2x plus 2 sin x dx. Again, we have two functions, which is 2x plus 2 sin x. So applying by parts again, it will be x squared plus 2x sin x minus, now this will be u, which is 2x plus 2, and our dv will become sin x dx. So our du will be 2, and our integral of dv will become v, and sine integral is minus cos x. So again, substituting into the by integration by parts formula, it become v du, sorry, v and u, which is 2x plus 2 minus integral of v du, which is 2. So it becomes x squared plus 2x sin x minus becomes plus. It becomes 2x plus 2 cos x minus becomes plus. And we have again a minus sign, 2 cos x.
So here about the minus and the plus sign, you distributed the negative which is outside the bracket?
Yeah. Are you talking about this step?
Yes, like it is 2x plus 2, and then it's become positive because of the negative outside and the negative inside, right?
1 minute.
Like before the integration, why there is a plus sign? Why it's not negative?
Are you talking about this?
No, under this one, the plus sign.
Can you use the marker?
The last step. Oh, I can.
Yes. I think you're talking about this plus, right?
Yes.
Okay.
Yes.
This minus multiplied with this minus becomes plus here. Okay. So it becomes 2x plus 2 cos x. This minus becomes plus, and this minus is still there. So I wrote minus 2 cos x dx.
Got you. Okay.
Okay. X square plus 2x sine x plus 2x plus 2 cos x, and taking minus 2 common because that is constant, inside is left cos x dx. So in x square plus 2x sine x plus 2x plus 2 cos x minus 2. Integral of cos x is sine x plus c. So it becomes x square plus 2x sine x plus 2x plus 2 cos x minus 2 sine x plus c. That's the answer.
Okay, got it. Thank you so much.
No, if you want to further simplify it, you can just write x square with sine x, then 2x sine x, then 2x cos x plus 2 cos x minus 2 sine x. If you want to further simplify, then you can. But it's correct if you write.
No, it's okay.
Yeah, okay.
Okay, thank you.
Thank you. Okay, now let's get back to the book. Okay. This question involves both integration by parts and it's U substitution that we have studied in the last session. So let's solve this question first, which is the integral of tan inverse x dx, and we have to integrate it from, we have to evaluate the function from upper limit to lower limit. Lower limit to upper limit, that is from 0 to 1. So let's solve this first. In the previous questions, we were studying the functions that has no upper limit or lower limits. That has only function, we have to integrate it. There was nothing like that. We have to apply the limits and have to simplify it. But now the question is that we have to integrate the function and then have to put upper limit and lower limit. So these functions are called the definite integrals when the limit is given. And when the limit is not given, these functions are called indefinite integrals. So applying the integration by parts and U substitution techniques on the definite integrals questions, and let's understand how integral by parts formula is applied on this question. The question is 0 to 1 tan inverse x dx let's take U as tan inverse x and du dv as dx, because we don't have any other choice that we can take u, because there's only one function. Another function is dx, so we don't have any choice that which one should we choose as u or dx. There's only function. So we took u as tan inverse x and dv as dx. Now du will be 1 over 1 plus x square dx. The differential of inverse trigonometric inverse tan function is 1 over 1 plus x square. And the integral of dv is v, and the integral of dx is x. Now we have, applying integration by parts formula, it becomes v u minus integral of v d u. V is x, u is tan inverse x, minus integral of v, which is x, and du, which is 1 over x square plus 1 dx. But the question was that we have to evaluate the function, which is tan inverse x, from 0 to 1. Now the integration by parts formula becomes u dv. So the formula becomes, this is upper limit and this is lower limit, a to b. We just have to put the limits on the integral by parts formula. Is it clear?
I think when you will solve, it will be more clear for me.
Okay. So here we'll be applying the limits a to b, which is from 0 to 1, and integral from 0 to 1. So it becomes x tan inverse x 0 to 1 minus integral of 0 to 1 x over 1 plus x squared dx. Now applying this, upper limit minus lower limit. Upper limit is 1, tan inverse 1, minus lower limit, which is 0, tan inverse 0. This is upper limit minus lower limit. And then again, we have this integral formula, which is from 0 to 1, x 1 plus x squared dx. Tan inverse 1 is pi by 4. And 0 multiplied with anything makes it 0. And then minus integral from 0 to 1, x 1 plus x squared dx. Pi by 4 minus, if we see that here, that's there is a derivative of a function inside the function. So we can apply the U substitution here. From here, we can apply the U substitution, taking U as 1 plus x squared. So du will be 2x dx. If now I have got the derivative of a function. The function was 1 plus x squared. When I differentiated it, I got 2x dx. Now I have the differential of a function, which is x dx becomes equals to du over 2, because I just divided 2 both sides of the equation. So du over 2 becomes x dx. So it
Is it
becomes
always gonna be like that? Like we will use by parts, and when we arrive to this step, we will use always it will be U substitution, or it can also be again by parts.
yeah, it can again be pi parts.
Okay.
Yeah, but here it was easier for us to use the U substitution because we know that if we take the 1 plus x squared as U, then we have a derivative of a function inside the function given, which is x dx.
Okay.
So it becomes, okay, 0 to 1 integral, and x dx is du over 2, and u is 1 plus x squared. So what our functions becomes like this: pi by 4 minus integral of 0 to 1. Can I take the constant out? So half is taken out. Inside is left du over u. Okay, now let's get back to the book and find out the integral of 1 over u. Okay. 1 over x dx is equals to ln x plus c. So again, we have 1 over u du. We have to take the integral of it. So our formula will becomes ln u plus c. Minus half ln u, and then we have to evaluate it. Okay, when we are going to evaluate it, the function, our u is x squared plus 1. This was the limit x2 to x1. Now our function is in the form of u. We need here u1 and u2 in the limits. So your u1 will become x1 whole square plus 1. Our x1 is 0 plus 1. So our u1 will become 1, and our u2 will become x2 whole square. So x2 is 1. 1 whole square plus 1 will become 2. So our new limits is from 1 to 2, not from 0 to 1. It will be from 1 to 2. So we have to evaluate the function from 1 to 2. And we have plus c, a constant of integration. So it becomes pi by 4 minus half ln 2 minus ln 1. Pi by 4 minus half ln 2, and the ln 1 is 0. So the answer is pi by 4 minus half ln 2. Do you have any questions?
No, everything was clear.
Okay. Now let's get back to the book. Okay. In this question, we have asked, we are now going to do the exercises questions. So we are going to start with question number 1, which is evaluate the integral using integration by parts with indicated choices of u and gv. In the question number 1, we are given what is our u and what is our dv. And the function is that x e raised to the power 2x dx. It's from integral x e raised to the power 2x.
Sorry, but I have a question I want to ask before I forget. What if we have the integration of cos 2x?
Integration, 1 minute. Integration of cos 2x.
2x. Yes.
Okay. So cos 2x becomes sin 2x.
Fine.
Okay.
Okay.
And okay, and then we have this 2x function, which we will be differentiating it, and it becomes sin 2x over 2.
So we write the derivative of the inside of 2x.
Yeah, the derivative of 2x.
B2.
Yes. Yes,
Okay, okay. Thank you. Thank
no
you.
problem. Okay, so the function is x e raised to the power 2x dx. And the question was that u is given to us, which is x, and dv is given, which is e raised to the power 2x dx. Now we have du is equals to 1, and taking the integral of dv will become v, which is equals to e raised to the power 2x, and then the differential of 2x. So it becomes e raised to the power 2x divided by 2. And it becomes 1 dx. So it is du is equals to dx. Now applying the integration by parts formula, it will become v is e raised to the power 2x divided by 2. U is x minus integral of v, which is e raised to the power 2x divided by 2 du, which is equals to dx. So it becomes half x e to x minus, taking half common, I mean half outside the integral sign, so it becomes e to x dx, half x e to x minus half e to x. The integral of e to x is e to x divided by the differential of 2x plus the integration constant. So half x e raised to the power 2x minus half e 2x divided by 2 plus c. It becomes half x e to x minus 1 over 4x, 1 over 4 e raised to the power 2x plus c. This is the answer. Is it clear to you?
Yes. Okay. I already solved some questions of this exercise questions from the book. If there is a question like have some different technique or different way to solve, can we solve it? And if it's all the same, can we move to the trigonometric integration, please? Because I want to catch up with my professor.
Okay.
Like I'm too late. Yes.
Let me just check it out if there is any question that is difficult.
What about 21?
X e raised to the power 2x divided by 1 plus 2x whole square. This is, okay, let's try it out. X e raised to the power 2x 1 plus 2x whole square dx. Question number 21, integral of x e to x 1 plus 2x whole square dx. Okay, now applying integration by parts techniques. Let's say our u is xe power 2x and our v is dv
Why
is 1.
didn't you, sorry, why didn't you choose u 1 plus 2x?
Yes,
And then, like, we can do u squared. Oh, sorry, that's by parts. But still, why didn't you choose 1 plus 2x?
why didn't I choose u as 1 plus 1 over 1 plus 2x square? Because if I choose u as 1 over 1 plus 2x whole square, and it becomes 1 over 1 plus 2x minus 2. Okay, and now taking the differential of it, it will become 1 plus 2x power.
Why 1 over y? It can be only 1 plus 2x squared. And
Because
then the rest will be dv.
no, because x e raised to the power 2x is, if I write a function like in this form, x e raised to the power 2x, this is the function in a simplified form. This is u and this is v. I mean, this is dv. Is it clear?
Yes.
So why I didn't choose u as 1 over 1 plus 2x, 1 plus 2x whole square? The reason was that if I take the differential of it, if I take the differential of this, it becomes power first minus 1 from the power. And then again, I have to differentiate the function, which will become 2. So it becomes minus 2, 1 plus 2x minus 3, and it becomes 4. Did you realize that the power is increasing? It was 2 and it has become 3 now. If I differentiated it again, then it is gonna be power 4.
Because our aim, we want to be like more simplified, right? Not
Yes,
more.
yes,
Okay.
that is reducible, not increasable.
Okay, thank you.
So let me just erase it out. Okay. Now we have to take the derivative of this function, which will become du. Again, we have two functions. We will be applying quotient rule. I mean the product rule, sorry, product rule, which is uv is uv bar plus v u bar. So it will become x as it is, the differential of e raised to the power 2x, taking the differential of e 2x again, plus e raised to the power 2x as it is, and taking the differential of x, which will become 1. And there is dx. So it has become 2x e raised to the power 2x plus e2x dx.
Why here I used product rule? Why like
Because we when u is equals to x e raised to the power 2x, okay, so now there are two functions, both are multiplying, the x and e to x, so I have to apply the product rule here because I am taking the differential of u.
okay.
Okay, so now checking the integral of this part, dv will become v and 1 plus 2x becomes minus 2 dx. I'm taking the power to the positive power to the numerator side, so it's going to be minus 2, and the integral will be 1 plus 2x. We have to add the power, so it becomes 1, and we have to divide with the same power, and then we have to take the differential of the inside function. So it will become 1 plus 2x minus 1 divided by minus 1, and it is 2 only. Is it clear?
Yes.
So v will become minus 1 over 2, 1 plus 2x. I just simplified it. Minus 1 was a negative power in the numerator. I just bring it down to the denominator to make it positive power, and half minus half. So it is v now. Now substituting into the formula, it was uv minus integral of v du. U is x e to x, and our v is minus half 1 plus 2x minus integral of v, which is minus half 1 plus 2x, and du, which is two x e raised to the power 2x plus e2x dx. Is it clear?
Yes.
Okay. X e2x minus half 1 plus 2x, minus minus becomes plus, integral of 1 over 2, 1 plus 2x. Okay, can I take anything common from this?
You mean these two? I think half.
From this function, can I take e to x common?
Oh, sorry. Yes.
And inside is left only 1 plus 2x, right? So 1 plus 2x is cancel out with 1 plus 2x, and we have x e raised to the 2x minus half 1 plus 2x plus half and e raised to the power 2x dx. This is what is left. Okay, now x e to x minus 1 over 2, 1 plus 2x plus, okay, taking half outside and taking the integral of e to x dx minus x e raised to the power 2x divided by 2, 1 plus 2x, it becomes 1 over 2. Okay, the integral of e to x is e to x as it is, and we differentiate 2x, and there will be plus sign of the integration. So minus x e raised to the power 2x divided by 2, 1 plus 2x plus half. So it will become e raised to the power 2x, and the differential of 2x is 2 plus c. So it will become minus x e raised to the power 2x 2, 1 plus 2x plus half, plus 1 over 4 e 2x plus c. That's the answer. Is it clear?
Yes, it's clear.
Okay. Is there any question that we should do?
What about 18?
This one, right?
Yes.
E minus theta cos 2 theta d theta. Okay. E minus theta cos 2 theta. Okay, now we have to choose our u and v. If you can see that both the functions are irreducible. Right? So whichever I choose, e minus theta or cos 2 theta. Let's select our u as e minus theta, and
Oh, I'm sorry, because I don't want to waste time. I think I got this one because we already solved one similar to this, e to the x and then sine x, right? It will be the same way. But here we
I
have cos 2x, or sorry, 2
yes,
theta.
yes, we
Yeah,
have solved this one. The similar question in the example.
yeah, yeah. Okay, then let's move on. I think we will just, sorry about that. I thought
Uh,
maybe something.
it's okay. So you were saying that let's start with the trigonometry integral. Okay.
Yes. How many minutes left actually? Because, okay, we still have time. Okay,
We have 15 minutes, I think. Yeah.
and that's good. Okay.
So we have to evaluate the function which is cos
I'm
cube.
sorry, before you start, I don't know anything about this topic, like even though the basic things and what do I need to have to memorize about this topic. before
okay.
like okay.
Okay, I will be keep on discussing the things with you as we start solving examples. So example number 1 is, what was example number 1? This cos 3x dx. Okay. First thing is that can we apply the U substitution? There isn't any use of using the U substitution here, because let's say that U is our cos x, okay, and then we differentiate that function, it becomes minus sine x. So we don't have any differential of cos x here in this function, which is sine x. So we can't apply this. Now we have to apply the trigonometric integration, which is cos square x, cos 3x dx. Can I write my function as cos square x and cos x dx? I'm just going to break my cos cube x in this form, cos square x and cos x. Because I have the power same, then because I have the base same, which is cos x, the power will be added, which will become 2 plus 1, which will become 3. And there's an identity that is sine square x plus cos square x is equals to 1. So instead of cos square x, I can write 1 minus sine square x. So sine cos square becomes 1 minus sine square x cos x into dx. Can we now apply the integral, the U substitution?
Yes.
Because we have cos and sine. Both are the
We can.
differential
So
of
when we
each
have
other.
like, okay, I got it.
So U is sine x. And
What if not, like, what if we didn't have sine cos? We can use by part or something else, right?
If you don't have,
You just say that sine because the derivative of cosine
yes,
we
yes,
can use
yes,
substitution.
yeah.
If not, can we use by part?
Yes, if there isn't if the function derivative is not there, then yes, we have to apply the integration by parts.
Okay, thank you.
Yeah. So du becomes cos x dx. So it becomes 1 minus sine x is u square. Instead of cos x dx, I can write du. So it becomes the integral of 1 minus u square becomes the integral of 1 on the constant becomes u. Integral of u square becomes u cube over 3 plus c. Now we have to substitute again.
Why didn't we, before we integrate like 1 minus 2, 1 plus u?
You
Expand
mean
or
even 1 minus u square?
yes.
Uh,
Because I saw somewhere that they had the same thing, but they use like they expanded and then they integrate. Or we will have the same answer.
expand them in which form?
Like let's say a squared plus 2ab plus b squared.
Okay.
Then
So
it's gonna be like,
if I have to expand it, is in this form: 1 minus
yes,
1 minus u plus u minus u squared. Then I'm going to get the two functions that are multiple of each other.
so I complicate it more when I
Yes,
do this,
this
right?
is gonna be more complicated.
Okay, okay,
Yeah.
thank you.
Even if in the integration, if the two functions are multiple and they have the same constant or same power, then you can just multiply them to make it easier for you. So it becomes 1 minus u squared du. 1 becomes u and u square becomes u cube over 3 plus c. So now we have to substitute again. U is cos x. Yes. So it becomes, sorry, u was sin x. Yes, u was sin x. So sin x minus sin cube x over 3 plus 3. This is the answer. Is it clear?
Yes,
You just have to memorize this identity for now. If you have
okay,
if you have the question in terms of only cos x, then you just break that power into sine square or cos square x, and then simply then get the answer in sine and cos form, so you can apply the u substitution. Okay, the question number 2 is that in which we have two functions, sine and cos, both are there, and sine power is 5 and cos power is 2. Okay, let's understand how we are going to solve this question. It is sine 5x cos square x. It's sine 5x cos square x dx, and how to take the integral. This is example number 2. Okay, we know that sine square x plus cos square x is equals to 1. So can I write my identities like in this form? Sine 4x and sine x cos square x dx. So sine square x is equals to 1 minus cos square x. But I need sine 4x. So I will be squaring on both sides of the equation. It becomes sine 4x is equals to 1 minus cos square x whole square. Whole square. And then I have sine x. And then I have cos square x dx. Okay, now I can say that u is equals to cos x, because I'm applying the u substitution, because I know that the integral of u, I mean the cos x is there, which is sin x dx. So I can apply easily the u substitution. So du becomes sin x dx. Okay, then sin x dx will be equals to minus du. 1 minus cos x is u square and whole square, sin x dx is minus du, and cos square x is u square. Is it clear?
Yes.
Okay. So so now I can say that 1 minus 2u square plus u4. I have applied a minus b whole square formula. A square minus
Uh-huh.
2b plus b square. And then I have u square minus du.
Okay. Why didn't we apply because square 2 times? Okay. I wanted to ask like why here we didn't integrate immediately. And then I saw that square 2 times.
Why didn't we integrate? Are you asking about this part?
Yes.
Because I want to simplify it before I don't need the terms in the multiplication form. I want each term to be added. But I'm just simplifying it, and then I will be taking the integral of it.
Okay.
So taking the minus sign out, which is constant, multiplying 1 with u square, multiplying minus 2u square with u square, it becomes minus 2u4 plus u6 du. See, now there was the terms, it was in power term, and then there was a multiplication term. Now I have all the terms in the added and subtraction form. It is now easier for me to apply the integration. So u square becomes u3 over 3 minus 2, u4 becomes u5 over 5 plus u6 becomes u7 over 7 plus c. There isn't integration sign.
Okay, what if we have like a huge number of let's say sine to the power of 16 and then cos to the power of 5, let's say.
Okay, sine, if we have something like this, sine raised to the power 16 x and
Let's say cos to the power 6 or
6x.
5.
Okay. Okay, I need my sign in terms of sine square x. So I can write 1 minus cos square x instead of, I can apply only the identity in this form. So I can write my
so anything like 2 multiplied by something that gives me 16. Okay.
I can write it like this, and then I have okay.
Okay, got it. Thank you.
No problem. So what was our u? U was our cos x. Power 3 divided by 3. 2 over 5 cos power 5 x. 1 over 7 cos 7x plus c. That's the answer. Is it clear?
Yes.
Okay. Okay, let's end it here. And I will let you know about the tomorrow's timing. I think it's it will be the same timing as yesterday. It is okay for you?
Which time it will be? 4.5?
Yes, the same time as tomorrow, as today.
Okay, that's okay with me.
Okay. And
so tomorrow we will continue on like trigonometric integration, like we will solve some different questions than this one, right?
Okay, yeah, sure. Okay, that's perfect for me.
Okay.
Okay.
Thank you.
Bye.
Thank you so much.
Thank you. Bye. Bye.
Bye.